Let's start by plotting the given information on the Cartesian plane. Let P be any point on the desired curve. The tangent to the curve at the point P has a slope equal to dy upon dx, and the normal to the curve at the point P cuts the x-axis at the point G. Let's assume that the coordinates of P are x, y. So if we drop a perpendicular from the point P onto the x-axis, and let's assume that the foot of the perpendicular is t, then the coordinates of t are x, 0. Now since the normal PG is perpendicular to the tangent, therefore the slope of the normal is equal to minus 1 upon dy upon dx. Therefore, the equation of the normal at point P is given by capital Y minus small y is equal to minus 1 upon dy upon dx, which is the slope, multiplied by capital X minus small x. This can be written as capital X minus small x plus dy upon dx times, in brackets, capital Y minus small y is equal to 0. Now, in order to determine the point G on the x-axis, we set capital Y equal to 0, and we therefore get capital X minus small y times dy upon dx is equal to 0, which implies that capital X, which is the abscissa of point G, is equal to x plus y times dy upon dx. Therefore, the coordinates of G are x plus y dy upon dx, 0. Or in other words, the distance OG between the origin and point G is equal to x plus y times dy upon dx. Now we are given in the problem that OG is equal to 2 times OT. Now since the distance OT is equal to x, this implies that x plus y times dy upon dx is equal to 2x. This implies that y times dy upon dx is equal to x. Separating the variables, we get y dy is equal to x dx. Now integrating both sides and introducing a constant of integration, say c upon 2 on the right hand side, we get y square upon 2 is equal to x square upon 2 plus c upon 2. 2 cancels across the left hand side and the right hand side in the denominator, and therefore the equation of the curve is y square minus x square is equal to c, which is a rectangular hyperbola. And this is the required answer.